So let me start by saying this. So DARwIn-OP is officially a NSF National Science Foundation supported research and development project. I'm the PI from Virginia Tech, and also we're working with Purdue University and University of Pennsylvania and the company Robotics, who's actually building and selling. So we're going to talk about all the details today. So I think it's very important. By the way, let's keep the door open. I think that's a good idea. Keep it open so people can sneak in. So I think it's interesting and important to understand the history of the development of Darwin. So Darwin started in actually 2004 at Virginia Tech. So I've been very interested in human locomotion, so I thought that the best way to learn about human locomotion is try to build a miniature humanoid robot and try to make it walk. By the way, DARwIN stands for Dynamic Anthropomorphic Robot with Intelligence. So in 2004, at the time, and these days you can buy small toy, hobbyist humanoid robot. At that time, it's very rare. So we wanted to do some initial feasibility study of if is it even possible. What is it? Sound is not coming in?
You have to turn it on.
Okay. Very good. So we had to do an initial feasibility study. What kind of motors can we use? What kind of controllers can we use? So we decided to use Robotics' dynamic motor, and this was an early robot called Cycloid, and we tried to come up with different software. So as you know, this one does not have any sensors, no feedback, and as you know, if there's no feedback and there's services, then you know what happens. Something like this. We all experience like this, right? So, however, with this success, we decided to go with it. So in the following year, 2005, we started doing the real design, starting from the kinematics, all the detailed design, FEM analysis, and this is what it came up with, Darwin 1. This was in 2005. So the software we use is LabVIEW real time. So the graduate students work on the ZMP-based walking gates. Most of the undergraduate students work on contributing to the design and fabrication of a robot. And Darwin 1 finally can stand up and walk in 2005. So again, at the time, this was very impressive and it was something very new. It's going to walk. It also walks with a little bit of like a straight knee kind of walking motion that we call great. But notice that it still has a tether, so it's still off-board computing and off-board power. As you know, weight is a big issue. But with this success, in 2006, the following year, we decided to it was time to add sensors, computing equipment, and make it smart so it can do real research. So Darwin 2A 2006 now has 2 firewire cameras, IMU, 6 rate gyros, accelerometers, 4 processors on the foot, lithium polymer batteries, 1.4 GHz Pentium M chip on board. Give all the sensors it needs, all the computing power it needs, so it can actually use it for research. So now if you move an object in front of its head, the camera can track the object. This video over here is the view from Darwin when it's walking. So the reason why it's shaky is it walks like Frankenstein like this. And it tries to locate this orange one and put a blue dot. So this was Darwin 2A. As you probably know, there's a competition called RoboCup, Autonomous Robot Soccer Competition. So in a very short amount of time, graduates put together a fully autonomous robot soccer playing program. It's not remote controlled, there's no tethers. Just by the vision, it tries to do localization and try to keep the ball into the goal. And this was our from the students. So with this, we were the very first team in the United States to qualify for the humanoid RoboCup, the humanoid division in 2006. So we use this for many things. So this is when Discovery Channel came to film the robot. It's been on all different UCN and things like that. But as you know, the Murphy's Law, whenever there's a camera, it always fails. So if you saw it on TV, you probably saw it missing a little bit. Alright. So this is the next version, Darwin 4. Which is much faster, much stronger. It has a mechanical ability to run, and it's trying to show some cool moves that's really like Jackie Chan, martial arts kind of thing, and it walks away. So with this success, so we've been participating in RoboCup since 2007. So these are some photos from the RoboCup. So in case you don't know about RoboCup, as I mentioned, is an international autonomous robot soccer competition with the goal of by the year 2050, we want to have full-size humanoid robots play soccer against the World Cup human champions and win. So towards that goal, they're upping the rules and we're going towards that goal. So this is in 2007, the first time we entered in RoboCup with our Darwin series robots. Darwin 2A and Darwin 2B against one of the Japanese we wrote over there. This is in China, Suzhou, China in 2008, playing soccer, autonomous soccer. This is a beautiful Louis Vuitton Cup trophy that we plan to get next year. This is what you get when you get the best humanoid robot, and I believe that DARwIN-OP will be able to bring this to the United States, if everything will do. Alright, so just to give you an idea of the RoboCup, you've probably seen a lot of movie clips, but it's a really impressive research event. All self-implementation, autonomous behavior, dynamics and control, motion. It's really a research event packed in a more entertaining, exciting, supporting event. So everything, this is down-track robot, you can see the visual tracking in real time, that's Darwin over there. So the latest version of the Darwin is actually Darwin 4. We actually brought Darwin 4. We brought here. This is Darwin 3. We developed in 2007, and this is the latest Darwin 4. It's really, really fast, strong. It's also very heavy, but it's a very capable, high-performance robot. So that's Darwin 4 over there, and the performance of this is remarkable. We also use this for many outreach programs. As you know, we all experience whenever there's a humanoid robot, the kids love them. So whenever we do these demos, the kids actually think these robots are alive and they actually try to talk to them and they interact. So we use this a lot, these robots for outreach activities. Another project related to the Darwin project is the Mini Hugo project. It's also an NSF, National Science Foundation funded project called PIRE. They actually have a PIRE workshop upstairs on the 6th floor if you have time, if you want to check it out. So this is another robot that we developed. Everybody knows Hugo from Korea Kites. So this is a miniature version of that, and we try to make it an open hardware platform, meaning that all the CAD files and drawings and everything is available online. So anybody can make it. And we did an experiment. So the Drexel University students actually, without any communication with us, they build a full Mini Hugo just based on our instruction and CAD files. And you can see the performance of the Mini Hugo. So, also we use this, oh by the way, 2 years ago, the Roanoke Symphony Orchestra stopped by campus. And during the Christmas, the holiday concert, and guess who the guest conductor was? Darwin actually conducted the orchestra. So you can see a lot of possibilities of using it for many different type of outreach and also for research. So we've been getting so many emails, phone calls, letters from people from all around the world, research laboratories, universities. They showed interest in this humanoid robot platform, Darwin, because it's very capable. So as I mentioned, we did a quick, unofficial survey right now, right before the session. A lot of people use different type of robots. Algebra now, RoboNova. What was the robot that you talked about? The Bioloid. Okay. The Bioloid, and there's another one. So there's some of them. But we try to get a lot of feedback from these humanoid robot users and try to create the best humanoid robot for research, education, and outreach. So with that goal, I wrote a research proposal with Purdue University and submitted. Oh, by the way, so Darwin's been on the cover of many magazines. This is just some of the latest. This was a little old one, but this is was it like 2 months ago? It was on the cover of the Robot magazine. So we wrote a proposal to NSF to develop a fully open source miniature humanoid robot for research, outreach, and education. 2 versions, Darwin Hp and Darwin LC, which I'm going to talk about in a minute. And we have 26 partner universities. And we decided to build 20-something units and give it to them for free so they can use it for research outreach activities. And every year we're going to have a workshop, get feedback from them. They're going to use it for many different tasks, which I'm going to also talk about later, and then improve this. But the really important thing is we want to form a user community of the Darwin robots by making it open source. We're going to talk more about all those things in detail. So at Virginia Tech, we use these robots for many different types of educational activities. Vision, autonomous behaviors, kinematics, human-robot interaction, dynamics and control, design. So we use these for a lot of things. So we know that this is a really good platform for doing these kind of things. So, as I mentioned, we're developing 2 robots. One is called Darwin Hp. HP stands for high performance. HP is actually based on our Darwin 4 robot. Unfortunately, this is not going to be open source. Okay, we're going to only make like 6 units and distribute to some research universities that can actually they need this platform for some kind of high performance locomotion task. But the more exciting part is the Darwin LC. LC stands for low cost, and this was supposed to be based on our Mini Hugo project, which was also an NSF sponsored project for the higher project. However, while doing that, we actually decided that we should really start from scratch, because Mini Hugo, though it's very capable, it was constrained by it had to be a miniature version of Hugo. But we found out that by starting from scratch, you can improve in so many different ways. So he scratched the idea of using Mini Hugo and he designed a completely new robot. And the performance turned out to be fantastic. So if you called it LC, we thought it's going to be misleading. So we changed the name to DARwIN-OP, and OP stands for Open Platform. So now we have Darwin HP and OP. Now, unofficially, Darwin-OP actually performs much better than Darwin HP at this point. But HP has a lot of other advantages as well. So today in this workshop, we're going to talk about Darwin-OP. So what's the goal of Darwin-OP? Again, throughout the day, we're going to talk more in detail. But first of all, the most important thing we thought, it has to have a very high load carrying capacity. Because if you really want to use this for research, you want to have different cameras, you want to have another processing board, different type of sensors. You might want to make it carry different objects to do some manipulation. So one of the goals is to have it can carry extra load. Most of the robots that's on the market, if you put another camera on it, it's right at the design threshold, it cannot walk. But this one, Darwin-OP can. Ample computational power. Some other competitive robots or on the market, some of them with the same philosophy as Darwin, they have very limited computing power. Some of them maximum like 500 megahertz, something chip. But our robot, as we'll talk about more, we have a 1.6 gigahertz atom chip, and we have ample power. And this was also from feedback from other users, especially from the Rope Cup, that they want to use this for implementing some sophisticated vision algorithms and autonomous behavior. So ample computing power. Good and useful sensors right out of the box. We're going to talk more in detail, but it has a really nice HD camera. It has 6-axis IMU rate gyros, accelerometers, and also has a microphone, two microphones and a speaker. Some people want to use this for sound source localization. Another university is going to use for linguistics, trying to communicate, use Darwin as understand how to make the computers understand human speech and those kind of things. High performance. This is important for many things, but mainly this is for the competitive events. RoboCup being RoboCup. The reason why I'm so excited is because I truly believe Darwin-OP is the highest performing humanoid robot of its class. It's awesome. You probably seen it walking. Whoops! You probably seen it walking downstairs on the carpet yesterday. But this carpet, this is really plush. Not a lot of robots can actually walk on a carpet like this. Sorry, but even Bioloid might have difficulty walking on this carpet, right? Yeah, so a lot of other robots, they can't even walk, but Darwin-OP can easily walk on this, and as we'll see some of the demonstration and the video clips, if it's on a hard, smooth surface, it's walking, it's awesome. You're gonna see it. Expandability, which is also important. So we want people to hack this, modify it, add things to it. Take out the hand, develop a gripper, put it on. Put another camera on the head. And also robotists, as we'll talk about, they're going to also sell additional parts like robot grippers, but we want you to hack it, modify it, add more stuff. Because it has enough high load carrying capacity, you can do what you want. Open source software and hardware. This we're going to talk about in more slides, but again, the idea is make everything open. So everyone can share and you can contribute. I'll talk about that one in the next slide. Affordable. Now, of course, these are expensive. These are not toys. These are research tools and education tools. But we try to make it as affordable as possible. We believe that it's much more competitive than any of the other platforms out there. Easy maintenance. It breaks. Everything breaks. So if it breaks, you don't have to send it to the company or send it to us, but you can assemble it easily, disassemble it, change out the parts. If a part breaks because it's open source hardware, you can make your own replacement part and put it in, or you can buy that broken part from the company Robotis and just replace it. So it's very, very easy maintenance. This is another really, really important strength of Darwin-OP. Also, as I mentioned, we want to form a community of users. So at the beginning of next year, we're already going to have 20-something DARwIN-OP platforms used in various universities out there. So we're going to start with that. But we believe that a lot of other robot hobbyists or different universities will start making this, and we want them to contribute software, hardware-wise to the SourceForge website. Right? That's going to be the main website for collecting all this data. And of course, we want to have fun with this because it's cool, right? So for the NSF project, these are our partner universities. It's a mixture of research universities, undergraduate-only universities, women-only universities. So we want to really diversify it. So I believe that we're building 9 HP units and 26 OP units and distribute it initially. And they have all different plans for using these for many different type of research and education activities. And again, they're going to give us feedback about how to improve the DARwIN-OP, and based on that, we're going to update the CAD files and all those kind of things. Let's talk briefly about open platform. What do we mean by open source hardware and open source software? So again, the idea is we want anybody to be able to make it. So you don't have to buy it from robots. You don't have to. You can make your own. But again, of course, the actuators, you have to buy it from this company because this company makes it. But if you want to make it, you can make it your own. If you want to buy it, you can buy the whole thing from the company. If you want to build it, but some of the parts are difficult to make, you can just buy those parts and build your own. You like building stuff, Michael. Like you already built a bioloid, the Darwin-OP head for your bioloid. Right?
Yeah, I like to use the 3D printer.
Yeah. So you might be interested in actually building one of these based on our instructions, because I know you like these kind of things. So that's the idea. So what's open? So in terms of mechanics, the full 2D and 3D CAD files will be available on the SourceForge.net, so you can download it. And based on that, again, the reason why I'm giving you the CAD data is we want you to also modify it and hack it and create your own different things. Fabrication manuals, we're going to talk that at the end of today's tutorial. We're going to provide all the detailed manuals of how to actually fabricate it, starting from setting up your CNC machine. If you're going to use a laser cutter, how to use this, and how to bend the materials and those kind of things. And we do have experience doing this from the mini Hugo prior project that I talked about. Detailed assembly diagram, the disassembly diagram, it's important for you to maintenance assemblies that fix things and mod it, so we're going to provide all those things. And also a maintenance guide. In terms of electronics, the main so another important thing about this, it's a PC base. It's not a proprietary something or microcontroller. It does have a microcontroller, but it has a generic PC. So we're going to talk more about that in the software section, but you can run Linux, Windows. We're also planning to do LabVIEW real-time, MATLAB, ROS, and anything goes. And again, today in the afternoon tutorial, so if you buy this from Robotics, it's going to come with a set of software. But in the afternoon, we're going to give you an example of how UPenn created their own software code and use that instead of the code that came with the DARwIN-OP as an example. So so the main PC, that's a commercial product, so all the specs are available. All the microcontroller boards, schematics are going to provide all the wire structure. All the firmware, source code, protocol are going to be all open. You can download it. You can change it if you want. You can flash the microcontroller board and do whatever they want to, right? So, and software development environment, framework, all the PC programs that the Robotics develops are going to be open, and of course the SourceForge site. If any school or university or people who develop code, the idea is to form a community and share it. So all of this is going to be open. Now, the PC itself is a commercial part, so we don't deal with it. Robotics, they actually buy it from the company. So the PC itself is, whatever that particular company, Fit PC, right? Fit PC, whatever that company provides is going to be open. The camera on it is a nice USB-based high-definition camera, but that's also something that we did not develop. We purchased it, so whatever that company provides, that's going to be what's going to be provided. And the dynamics motor is an actual product from the Robotics, so that's going to be an end product that's being supported as that motor, I believe. Okay, so with that was a quick introduction. So we started at 9 o'clock. That was the history of the development of Darwin, and then some of the scope of the project. So starting now today, we're going to talk about from the company Robotics, who's going to be building this robot. They're going to talk about the CEO from Robotics Pilgrim is going to talk about the general specifications, and he's going to be announcing about the cost and those kind of things. But I am not involved with any business. I don't get a single cent every time they sell a robot. I should have made a deal. I should get like 1% everything with them. So I have no financial ties with them. So they're going to announce all the cost and availability and the release schedule. And we're going to show some really neat demonstrations today. And after that, JK from Virginia Tech, one of the mechanical designers, he's going to talk about the assembly, disassembly, maintenance, and those kind of things. And after the break, lunch, of course we have the planetary talk by Mark Raber today. That's going to be exciting. And in the afternoon, Mr. Ha from Robotics, the Vice President, he's going to talk about the electronics, sensors, and all those kind of things. And after the whole afternoon is dedicated to some hands-on fun programming examples of the software that UPenn has developed, which has been very, very successful, which is also going to be all open source on the internet. So you can use this as a template and create your own code. So that's today's schedule. Of course, I'm going to close it by talking about the fabrication of open hardware, the mechanical part a little bit. Okay, so that's a quick introduction. Before we invite the President and CEO, any questions we have about the NSF project that we have? I'm sure you're going to have a lot of questions.